everyone, and welcome to today's episode of ZK Studies, where we are going to be going through calorimetry. Now, calorimetry is a procedure that we can use to calculate the energy content of a sample of food, and we do this by burning the sample. So this diagram over here is a setup of calorimetry, which we might do inside a science lab. And these are the steps that we should do. Firstly, we should use a mass balance to measure the mass of the sample of food. Next, what we can do is use a measuring cylinder, and we can put approximately 20 centimeters cubed of water into a boiling tube. Next, what we're going to do is we're going to use a thermometer in order to record the initial temperature of the water. Now what we do is we place the food sample onto a mounting needle. And then what we can do is turn on a blue Bunsen flame to ignite the sample. And then we're going to place the ignited food sample below the boiling tube of water. And we do this until the sample can no longer be reignited. And at this stage, what we can do is place the thermometer back into the water and record the final temperature. Now what we can do is repeat steps 1 to 7 approximately 3 times in order to calculate a mean. And then also repeat steps 1 to 7 for different samples of food. So in our class practical, we used different types of biscuits and compared their energy content. So once you've done this procedure and recorded all the necessary results, we can use a formula as follows, which is actually the specific heat capacity formula. And it states that energy equals mass times the specific heat capacity and the change in temperature. So say we wanted to find out the energy content of our food sample in joules. So energy in joules, so that would be the mass of water, which is 20, times the change in temperature, which is our final minus initial temperature, times 4.2, which is the specific heat capacity of water. And then to make a fair comparison between the food contents of different food samples, which are not necessarily of the same mass, we could do the energy content per gram and essentially divide this formula above by the mass of the food sample. So this is the basic procedure for calorimetry, but there are some different downfalls in the procedure. So for example, the food sample is undergoing incomplete combustion, energy is transferred to the mounting needle and surrounding air, so it's not just going to the water in the boiling tube. Energy is given off as light. The water might not be stirred, so thermal energy is not evenly distributed. And some energy is wasted in the time taken for the sample to ignite. So these are some of the weaknesses in our procedure. Now, in order to improve the accuracy of a calorimetry, we could use a bomb calorimeter. And special features of this apparatus can help tackle those problems. So over here, there's an oxygen supply, which ensures that complete combustion occurs. There is an insulating jacket to reduce heat transfers outside of the calorimeter. There are stirrers to help evenly distribute thermal energy through the water. There are ignition wires which directly heat the food sample. And the apparatus is surrounded by water. So, thermal energy is not transferred to other sources, for example, the mounting needle or surrounding air. And this greatly improves the accuracy.